So hello everyone. In this video we will be talking about the estimation of magnesium sulfate, and the estimation of magnesium sulfate is based on the complexometric titration method. And this estimation is actually a type of direct titration in which directly only the magnesium sulfate will be titrated with the standardized EDTA solution. So now let us begin with this estimation. So this can be divided into three parts. Firstly, we will carry out the preparation of reagents and solutions, and then we will do the standardization of EDTA solution, which is disodium acetate, and then we will carry out the estimation of magnesium sulfate by using standardized EDTA solution. Okay, so the step A and B. Okay, let me just erase the step A and B. These are the same steps which we have already done for the estimation of calcium gluconate. You can go and check out that video for the step A and B. We will not repeat the same steps in this video. Okay, so the estimation of calcium gluconate is also under the topic of our complexometric titration. So okay, so step 1 and 2 are exactly the same one. In this video we will directly begin with the step C, which is the estimation of magnesium sulfate by using standardized EDTA solution. So now let us see this part. So estimation of magnesium sulfate, let us read out the principle first. So it says that it is a complexometric titration in which magnesium sulfate is titrated directly against disodium acetate in the presence of strong ammonia ammonium chloride solution. So this strong ammonia ammonium chloride solution is required to maintain the pH at around 10, which is where you can say this is a kind of reaction condition for complexometric titration. Okay, so this is not necessary over here. The thing is that uh, the estimation of magnesium sulfate is a kind of direct titration in which directly only the EDTA will be titrated with magnesium sulfate. Okay, this is an important thing because in calcium gluconate, if you have watched the previous video for the estimation of calcium gluconate, you must have seen that estimation was carried out by replacement titration, which is another type of complexometric titration. So in case of magnesium sulfate, the kind of titration which we will do will be direct titration. Now so the endpoint is detected by modern black 2 mixture as an indicator, which is a kind of indicator used in this complexometric titration. So magnesium ions will react with EDTA, which is disodium acetate, and form magnesium disodium acetate complex, and the endpoint will be detected by the change in the color of the solution. That is how the complexometric titration indicate their endpoint. Okay, this is just the principle which tells us that this is a type of direct titration. So this is the reaction, and now let us see the methodology for this titration methodology. So what we have to do, we have to weigh accurately about 0.3 grams of magnesium sulfate in a conical flask and then dissolve in 50 ml of distilled water. So here we have simply taken our sample and then dissolved it in the required quantity of water, and then what we will do, we will add 10 ml of strong ammonia ammonium chloride solution. Again, this is to maintain the pH at around 10, and then we will add 2 to 3 drops of our indicator, which is modern black 2 mixture, and then we will fill the burette with standardized disodium acetate solution, and then start the titration with disodium acetate until the endpoint is reached, which is suggested by change of pink color to blue. Okay, this is how the endpoint is determined. This is the basic steps of carrying out this titration. Now let us see the calculations for the estimation, because whenever we estimate a compound, our main goal is to find the percentage purity of that sample. So the formula for calculating the percentage purity is V into E into AM into 100 upon W into RM. So V here stands for the volume of the disodium acetate used, which we can easily calculate from the burette reading. E is the equivalent factor of sample. Sample is magnesium sulfate. AM is the actual molarity of titrant, which we can get from our step 2, which we have not done in this video. You can go and check out for the estimation of calcium gluconate. There you will see it. RM is the required molarity of titrant, and W is the weight of sample, which is in grams. Okay, all these values we can easily calculate. The main thing is the equivalent factor. Let us calculate the equivalent factor of our magnesium sulfate. So equivalent factor means how many grams of sample will react with 1 ml of titrant. Okay, so here sample is magnesium sulfate and our titrant is disodium acetate. Okay, so the grams of magnesium sulfate that will react with 1 ml of a disodium aditate solution is the equivalent factor of magnesium sulfate. Now let us calculate the equivalent factor. So in order to know the equivalent factor, firstly we must calculate the molecular weight of the sample. So the molecular weight of magnesium sulfate I have already calculated. It came out to be around this one. So it means that in 1000 ml of 1 molar solution of magnesium sulfate, it has these many grams of magnesium sulfate. So instead of 1000 ml, if we need 1 ml solution, so we will divide this term by 1000. So this is the value which we get, okay, which it means that 1 ml of 1 molar solution of magnesium sulfate has these many grams of magnesium sulfate, okay. So 1 ml of 0.05 molar magnesium sulfate is equals to this value into 0.05 into this many grams, okay. We have done 0.05 molar because the standardized EDTA solution which we use in this titration has strength 0.05 molar, okay. This we have done in the video for the calcium gluconate. You can see that we have carried out the preparation as well as the standardization of this EDTA solution in that video. So it means that 1 ml of 0.05 molar EDTA solution is equal to 1 ml of 0.05 magnesium sulfate, and 1 ml of 0.05 magnesium sulfate we have calculated it has these many grams. Let me just erase it. It has these many grams. It means that with 1 ml of 0.05 molar EDTA solution, these many grams of magnesium sulfate will react. So this is the equivalent factor of magnesium sulfate for 1 ml of EDTA solution. So I hope this thing is clear to you. So by putting all the required values in this equation, we can finally calculate the percentage purity of our sample, and our sample will be estimated. So I hope you like this video, and thank you for watching.